So for today's lesson, we'll talk about the tech stack of our indie product. What are the various pillars and what are the decisions that were made and other alternatives that we could have made on choosing what technology or framework we're going to use? What are the main considerations? As in anything in software engineering, it's all about trade-offs. So, for example, in choosing a language, there's no one language that can be perfect. There's no language that is one size fits all. For example, Python. Python is a very lightweight language that is very good for data engineering or data science because it's there's already libraries that enable you to manipulate large data sets at scale concurrently, and also there's a lot of libraries that you can integrate with that enable you to do those tricky computations that would be much more inefficient in a different language, say Node.js. In the same vein, React as a language focus more on just front-end development, state management, running a single page application, and conscious that they are front-end and back-end languages. But my point is, because React would have different alternatives as well, like Angular, and Python would have, say, Java. So they all have different pros and cons, and to go through each language would be pointless. I'll just go through why I made those decisions on based on what our guiding principle is with regards to building this indie product. And even in when choosing, say for example, a cloud provider or an infrastructure layer, you can always go through, say, AWS, Amazon Web Services, or Microsoft Azure, Google Cloud Platform, GCP, depending on your needs. And sometimes it also depends on what you're comfortable with. And the, each each cloud provider has their own strengths and weaknesses as well. For example, GCP, if you're more considering search engine capabilities, right? Connecting to YouTube APIs, having a single sign-on because Google already has those capabilities and features built into their service. It's much more easier, or it makes more sense rather than building in AWS and then making a lot of API calls to GCP. So it's those small decisions that you think about when building a whole application end to end. You have to consider all the different things that you would need. And I guess like even just any aspect of software engineering, when you think about it, for example, if your priority is having a strong test coverage, inevitably you sacrifice time over it because you can't have 99% or 100% test coverage without sacrificing time. In the same vein, if you prioritize, say, for example, security and very tight APIs, it becomes harder for you to have a faster feedback loop because you're essentially making it hard for you to test internally and externally as well. So there's various kinds of trade-offs in the software engineering world. And today I want to discuss like what are the trade-offs that were made based on code, authentication, infrastructure, payments, and database. But the overarching theme here, as in my guiding principle as the architect of this, is serverless. So we're always thinking about the trade-offs, and being serverless allows you to have a more cost-effective way of running an application because in especially when you're starting off, you don't want to have running servers at the back end without actually users coming into your application. So the main purpose of having a serverless is your application just spins up when somebody comes in and visit your application. There's less infrastructure, and the main point is when it's down, nobody visits it. When nobody's visiting your application, all the servers are essentially down. So the caveat there would be it might be more expensive once you scale, when you have millions of users. But for now, we're aiming for cost effective. And then also it might be a bit more complicated to implement, because if you're a fairly junior engineer, serverless might be daunting to actually implement. So we'll go through like step by step on how to go about it. But yeah, for now, let's go through the tech stack.